Hello and welcome to another episode of Alex's Math Help for the people who should be in class but instead are still on spring break with the band. Today's episode, Lesson 6-2 Day 2, Work and Ramp Problems. Hello again. I hope the first episode helped you out. This one should be a lot shorter. I really only have 2 things to cover and then I'll go through some examples at the end to help you out. Okay, here's the first important thing you need to know. In most of the problems, it will describe or it will show you some sort of an object, like a plane or a box or something, and there will be 2 vectors acting on it, the movement vector and the push or pull vector, pull in this case. The movement vector is called the displacement vector, and the pull vector is called the force vector. The third important thing you need to know when looking at one of these is the angle measure between the 2 vectors, which is represented by theta, as usual. Okay, so what is the work formula? Well, it's pretty easy. It's W equals the absolute value of F times the absolute value R cosine theta and that's it. And what do they stand for? W is work, obviously. Remember when you see a letter as an absolute value, it usually means magnitude. So the magnitude of F is the magnitude of the force vector, F for force, and R for displacement. And then obviously the theta is the theta, the distance, or the angle between the 2 vectors. Sorry. Also, it's important to know that the book teaches this very differently, so don't look for that as a reference. And yeah, moving on. Okay, now let's do it with real numbers just for fun. So there's not really anything to solve for, you just sort of plug the stuff into the equation, but you have to identify F, R, and theta. So F is 20, R is 6, and theta is 40. Alright, so then you just plug it into the work formula. W equals theta of 20, absolute value of 20, times the absolute value of 6 cosine 40. 40. There we go. Alright, so all you have to do is plug that into your calculator and you get 92 what? Foot-pounds. That's the unit you use when you're working with work problems. Okay, next problem. How much work is needed to lift a 5-pound penguin 3 feet straight up? Okay, so first we have to figure out what the vectors are. So the displacement vector is actually going to be straight up because you're lifting it straight up. How far? 3 feet, so it's going to be 3. The force vector is going to be straight down because the weight of the penguin is going to be pushing back on it, and the penguin weighs 5 pounds, so it's going to be 5. So F is 5, R is 3, and theta. What's theta? Okay, well there's 180 degrees between 5 and 3 because they're straight up and straight down, so it's 180 degrees. Then we put it into the formula, and we get W equals the absolute value of 5 times the absolute value of 3 cosine 180. And if you calculate that, you get 15 foot-pounds. Okay, now we're on to ramp problems! A 50-pound penguin is on a 20-degree ramp, as shown in the picture. You'll usually see it as a box like that, so if it makes you happier as a box, fine. Just think of it as a box. So what is the force parallel to the ramp that is needed to prevent the box or giant obese penguin from sliding down the ramp? The force might be a friction or push or pull. Okay, so what you do is you draw a line straight down from the box like I did, and then make another line perpendicular to the surface of the triangle, and make those lines intersect and go into a triangle. Then the penguin weighs 50 pounds, so the magnitude of the hypotenuse of the triangle is 50. Since the top angle up there is 70, and we still have another triangle made out of 20 degrees and 70 degrees and 90, since the line is straight down, that's also going to be 70. And down there it's also going to be 20, because the perpendicular line makes another 90-degree angle, and then you've got 90 and 70 and 20. Just ask me if that doesn't make sense to you, but just look at it for a little bit and it should make sense. Alright, so we're trying to solve for the line parallel to the ramp, which is x. And to do that, we can go back to sines. Those are easy. So the sine of 20 equals x divided by 50. Because remember that sine is opposite over hypotenuse, and if we could do the 20 down there and do x over 50, and then we multiply both sides by 50, and we get about 17.1 pounds. And now it's pounds again, because this is not a work problem. Alright, this is actually the last problem. A force of 30 pounds parallel to the ramp just keeps the box from sliding down the ramp inclined at 20 degrees. Find the weight of the box. Okay, so I already drew the triangle with the box resting on it, so the first thing we need to do is draw a line straight down from the box, and another one that's perpendicular to the hypotenuse of the original triangle, forming a new one. Alright, so last time we were given the weight, but this time we have to find it. And if you remember, the weight is the line that's going straight down from the box, so we're going to label that x. Alright, next we see that the ramp is inclined at 20 degrees, so we can start filling in our angle measures. Alright, so it's a triangle, so 180 minus 90 minus 20 is 70. So this angle is going to be 70, just like last time, which in turn means that this angle is also 70, which means that this angle is 20. Alright, so a force of 30 pounds parallel to the ramp just keeps the box from sliding down. That's the number we were solving for last time, and if you remember, that was up here. So that's 30. So then we just have to use sines again to figure out what x is. So we do sine 20 equals 30 divided by x. And with some basic algebra, we figure out that x equals 87.7. And that's the answer, and that's the end of the lesson. So that's it, except for penguins!